All right. Question 7 then. So, use a binomial expansion of 2 minus 3x to the power 10 in ascending powers of x up to and including x cubed. Give each coefficient as an integer. So, we can do right, so we can start off here and we can say that 2 to the power of 10 is equal to 2 to the power of 10, 1024. Okay, now we can say that the NCR, 10 to the 1, times 2 to the power 9, times minus 3x. NCR of 10 to the 1 is going to be 10, should be. I want to check it just in case. Yep, 2 to the power 9 times 10 times by minus 3 minus 1,500, no, not 1,000, 15,360. X. Next one is going to be 10 to the power 10 NCR2, 2 to the power 8 minus 3x squared, and then 10 to the 3, 2 to the 7 minus 3x cubed. Okay, so very quickly, 10C2 is 45 times 2 to the power of 8 gives 11520 times by 9. That's going to be a minus, that's going to be a plus. 103680 x squared. And then for the last one, okay, 10 NCR3 is 120 times by 2 to the power 7, that gives 15360 times by minus 27 for 3 times 3 times 3 is minus 414720 x cubed. Okay. And then we want to use it to find 1.97 to the power 10. Give you answer to 2 decimal places. Okay. Okay, so that is like 2 minus 0.03, okay, to the power of 10, and that's like 2 minus 3 times 0.01 to the power 10, meaning that we've got x is equal to 0.01 again. So altogether we have 1024 minus 15360 times 0.01 plus 103680 0.01 squared minus 414720 times 0.01 cubed, and all of that comes to, and after putting it all into the calculator we get 880.353.328, and they wanted it to 2 decimal places, so 880.35. Okay. question 7, question 8. Question 8, expand 3 to the, where are we at? 3 plus 2x to the power 4 in ascending orders. Give each coefficient as an integer, so they just want the entire thing expanded out. We could multiply it out, multiply it out, multiply it out, but it seems a bit pointless. So let's do 3 to the power 4, and then we are going to have 4, 1, and that's going to be doing 3 to the power 3 and 2x. Then we're going to have 4, 2, and we'll have 3 to the power 2, and we'll have 2x squared. And we will then have 4 to the 3, 3 to the power 1, and 2x cubed. And finally, we will have 4, 4, 3 to the power 0, which becomes 1 and normally doesn't get written. Okay, and 2x to the power 4. Okay. So let's do the easy ones here. 3 to the power 4. Okay, 81. Then 4 to the NCR. Gives us 4. When it's to the 2, it should give us 6. And then we're expecting to see another 4 on 4C3. We do, and then another 1 down here. Okay, and all of that then gets multiplied by 3 to the 3, which is 27, 9, and 3, and 1. Okay, and then that's multiplied by 2x. 2 squared is 4x squared, 8x squared, and cubed even, and 16x to the 4. Okay, so 27 times 4 times 2, 216. 6 times 9 times 4, 216. X squared. Um, 4 times 3 times 8, 96. X cubed, and then finally 16x to the 4. So, writing it all out, 81 plus 216x plus 216x squared plus 96x cubed plus 16x to the 4. Right, continuing into part B for it then. Okay. Part B, hence or otherwise, write down the expansion. Expand that. Write down the expansion of 3 minus 2x to the power 4. Okay, so if that is equal to 3 plus 2x to the 4, then 3 minus 2x to the 4 is going to still be 81, but then we're going to get a minus 206x plus a 206x squared minus a 96x cubed plus a 16x to the 4. Part B, done. Part C then, hence by choosing a suitable value for x, show this. Show that is an integer and state its value. So they want to do 3 plus 2 root 2 to the power 4 plus 3 take 2 root 2 to the 4. So as we add both of these together, okay, we're going to get 2 lots of 81. Okay, 2 lots of 81 is 162. The x coefficients cancel themselves out, but the x squareds become 216 times 2, which is 432. X squared, the coefficients of the x cubes cancel themselves out, and then the 216s are 32x to the power 4, and we need to use root 2 as a x term here. Okay, so 162 plus 432 root 2 squared plus 32 root 2 to the power 4. 162 plus 432 times 2 plus 32, 2 2's are 4. Okay, and that gives us a final answer when we stick it all in the calculator to finish it off. 162 plus 432 times 2 plus 32 times 4, 1154. So and that was when we had x is equal to root 2 in case I wanted. Alright, question 9 next. Coefficient of x squared in a binomial expansion is 7. Find n. So we are told that 1 plus x over 2 to the power of n is equal to something or another plus 7x. Okay, and so we can find that 7x. We can do n to the power of 1 plus 1 to the power of n minus 1 and x over 2 to the power of x is equal to 7, I believe. Now, we can't do the n to the 1. Can't do the NCR1. Okay, so we have to do n factorial over r factorial and n minus 1 factorial. And that's going to need to be multiplied by 1, and that's going to need to be multiplied by x over 2. Okay, now all of this factorial here, if you consider something like 3 factorial, you've got 3 times 2 times 1, okay, and if you divide that by 2 factorial, i.e. 1 less, you divide it by 2 times 1. That gives you 3, because they cancel down, okay, which means we've got n. times 1, n, this should be 7x, equals 7x. So we get nx over 2 equals 7x. So we can divide through by the x's. N over 2 equals 7, meaning n equals 14 for question 9. But again, in good old fashion, I have looked at this and I don't want the x, it's x squared. So let's quickly do a rework on that equation. And in fact, all of that's going to be wasted work because it needs to be n to the 2 times 1 to the power of n minus 2 and x over 2 squared is equal to 7x squared. So bringing that in now, we end up with n factorial over 2 factorial n minus 2 factorial times by 1 times by x squared over 4 is equal to 7x squared. What's going on with this factorial business here? Again, if we consider the fact that we've got a, let's do 4 times 3 times 2 times 1, and then we are dividing it by a 2 times 1, which is just 2, and a 2 times 1 in here. We can cross that off, we can cross that off. Okay, and so we're going to have an n times n minus 1. So we've got an n minus n minus 1 all over 2 times, that's times, times 1 times x squared over 4 is equal to 7x squared. So we've got n squared minus n all over 8 equals 7x squared. X squared cancels, so we've got n squared minus n, 7 times 8, 56. And so, using a polynomial solver, we end up with 1, 1, in fact it's 7 and 8, isn't it? And minus 56. We get a value of n equal to 8 or n equal to minus 7. We were told it was positive, so we can disregard. N equals 8. Okay, that was a bit harder than it first jumped out at. Okay, find the value of n found in part A. Find the coefficient of x to the power 4. Okay, so the fact that we've got 8, so squared is always 1 less, so x to the 8th 4. And then it would be 1 to the power of 8 minus 4. squared over to the power of 4. Okay, so 8CR4, 8NCR4 is 70 times 1 times 2 to the power of 4, 16, x4 over 16, and so 70 divided by 16 is 35 over 8.